Hello everyone, welcome to our channel. So today we're going to discuss about what are instructions, what are instruction codes, what are instruction formats, what is direct addressing and what is indirect addressing. Okay, so before going to our actual concept, let's all discuss about what is instruction. So basically, let us assume that uh, there are students in the classroom. For example, faculty instructed the students to do something. So it's the job of students to accept that instruction. So what is instruction here? It's like a command. Okay, so to do something. So please write the assignment of unit 1. So faculty instructed the students. So it's the instruction given by the faculty in which students should follow that, isn't it? So what is instruction? So as per computer perspective, program. So what is program? So before going to discuss about instruction, first we should know about program. So what program is all about? A sequence of machine instructions. So a program is nothing but a group of or a sequence of machine instructions to do this, to do that. So all these machine instructions are given. We call it as program. So what is machine instruction then? A group of bits that tell the computer to perform a specific operation. A group of bits that tell the computer. So this group of bits tells the computer to do this or to do that. So to do the specific operation. So what operation it is? It can be a sequence of micro operations. So as we said that we have arithmetic micro operations, we have logical micro operations, we have shift micro operations. So in this arithmetic we have different operations. In logical operations also we have 4 operations: and, or, exclusive, or, complement. In shift operations also we have different operations like shift left, shift right, circular shift, arithmetic shift. So all these comes under shift micro operations. So whatever be the operation it is, so an instruction should be given to computer to understand what operation to be performed. So a group of bits that tell the computer to perform a specific operation. So a specific operation in the sense a sequence of micro operations. So these micro operations can be anything. It can be a sequence of arithmetic micro operations, logical micro operations, or shift micro operations. So I hope it's clear up to here. So the instructions of a program along with any needed data are stored in memory. So the instructions of a program along with any needed data are stored in memory. So where it is stored here? It is stored in memory. So what does CPU do now? So CPU reads the next instruction from the memory. Okay, so here we have 4 operations. So for example, this is memory. Okay, so what is memory used for? Memory is using for storage. So it will be some instruction will be stored here. Okay, so first I should fetch. Okay, so fetch from memory. Okay, so this is instruction cycle. We'll discuss later, but as of now I'm just giving the brief overview. For example, there are some apples in the box. So if I want to eat apples, what I will do? I will open the box and I will fetch the apples from the box. So let us assume that box is a memory. Okay, so I want to eat apples. So what I will do? I will open the box and I will fetch the apples. Next, decode. So what is decoding? Let us assume that out of that apples, some apples are not good. So some apples are good. So what I will do? I will throw out the unwanted apples and I will eat only the wanted apples. That means I'm decoding it. Execute. Okay, so execute, and finally store. So if there are 10 apples, I want to eat only 4 apples, and remaining all 6 apples I will again store in the box. Later on tomorrow, if you want to eat again I will fetch the box, I will decode it, I will execute it, and I will store it. Okay, so this is the instruction cycle basically. So that is what happens here. The CPU always reads the next instruction from the memory. So it is placed in an instruction register. So we have a register here. So we call that register is instruction register. So as I said that we have many registers, right? So memory register, memory address register, control address register, okay, PC, program counter. So we have many registers here. Out of it, we have instruction register. So the CPU reads the next instructions. These next instructions are placed in instruction register. So and to manage all these things, we need a control circuitry. Okay, a control circuitry in control unit then translates the instruction into sequence of micro operations necessary to implement it. So there may for example, one micro operation is needed to implement, or else two micro operations are needed, or else some sequence of micro operations are needed to complete our action. There is no rule that we should use only one micro operation. So there may be sequence of micro operations which we can use, and finally we should complete the instruction. So who is going to do that? This control circuitry is the main responsible for doing these things. And what is instruction code? So this is most important. An instruction code is a group of bits that instruct the computer to perform a specific operation. So it's a group of bits. Okay. So for example, we have 16 bits, we have 32 bits, so we have 64 bit. Okay. So if you see in operating systems, you may see like my operating system is 32 bit, my operating system is 64 bit, like that. So an instruction code is a group of bits that instruct. So this group of bits always instruct the computer to perform a specific operation. So this instruction code is mainly divided into two parts. One is address part, one is opcode part. So anyways, we'll discuss these two later on. So first, what is operation code? Specifies the operation. So either add to be performed, either mul to be performed, either increment to be performed, either logical and to be performed. So what operation to be performed mainly depends upon the operation code, which we shortly call it as opcode. And address specifies operands, registers or memory word. Okay, so this is instruction code. So anyways, we'll discuss this in briefly. And as you know that program, a set of instructions, as we discussed, a set of instructions that specify the operations, operands and the sequence by which processing has to occur. For example, I have A plus B. So what are A and B here? A and B are operands. So what is plus here? Operator. So what I am doing here? I am doing addition operation. Let us assume I have A minus B. A and B are operands, minus is operator, and I am doing subtraction operation. So a set of instructions that specify the operations, operands and the sequence by which processing has to occur. So instruction code, as we already discussed, a group of bits that tell the computer to perform a specific operation. Okay, so it's divided into opcodes and addressing modes. Okay, so simplest stored program organization. So here our memory is all about 4096 into 16. So as you know that it is divided into program as well as data. So program is called instructions and data is called operands, and we have an accumulator and processor register. This is binary operand 0 to 15, and instruction format we'll discuss now. So this is simplest stored program organization. So in examination they may ask you like that. So this is important. Draw the diagram for stored program organization. So this is the diagram for stored program organization. So you can pause the video and you can note it down. And coming to the instruction format. So this instruction format is most important. So as we know that computer instruction is often divided into two parts. Just now I said an opcode and address. An opcode that specifies the operation for that instruction, and the address specifies the location in memory. And here comes, in the basic computer, remember, in the basic computer, since the memory contains 4096, so how many words we have here? 4096. So how we get 4096? It's nothing but 2 power 12. So we need 12 bits to specify which memory address this instruction will use. Okay, so listen carefully here. In the basic computer, how many words we need? 4096. So how we get 4096? 2 power 12. So what does it mean? We need total 12 bits to specify which memory address this instruction will use. So that means the first 12 bits occupies address. Okay, so we'll always start with 0, right? So 0 to 11. So 0 to 11 means 12 bits. So this 0 to 11 occupies address. Next, in the basic computer, bit 15 of the instruction specifies the addressing mode. And remember, 12 to 14. So that means 12, 13, 14. So how many bits? 3 bits. Okay, so these 3 bits occupy opcode. Opcode means operation codes. So that means which operation to be performed, either addition operation, increment operation. So these 3 bits decide. So previously it was 11. So 11 plus 3, 14. So we left with 1 bit. So what is this 1 bit? So this 1 bit is nothing but I. Okay, so in the basic computer, bit 15 of the instruction specifies the addressing mode. Okay, so this I specifies the addressing mode. So here we have two things, 0 and 1. So 0 is direct addressing, 1 is indirect addressing. So since the memory words and hence the instructions are 16 bits long, that leaves 3 bits for the instructions opcode. Okay, so opcode contains 3 bits. So your total instruction format is divided into 16 bit. Out of it, 0 to 11 occupies address, 12 to 14 occupies opcode, and 15th bit we call it as I bit occupies addressing mode. So this addressing mode, if it is 0, we call it as direct addressing mode. If it is 1, we call it as indirect addressing mode. And this direct addressing and indirect addressing is most important, which we will discuss now. So the address field of an instruction can represent either direct address or indirect address. So what is direct address? The direct address, the address in memory of the data to use, the address of the operand. So what is direct address? The address in memory of the data. So the address which is present in memory of the data which we want to retrieve. Indirect address, the address in the memory of the address in memory. See, the address in memory of the address in memory of the data to use. So I will say a simple example. For example, your friend X wants to reach your home Z. Okay. So what you will do? First, he will call you. Okay. So I am coming to your house. Please say the address so that I can reach your house. So what you will do? You will say, please come to the landmark A. Now X will come to landmark A. Now he will call again. I came to A. Where is your house? Now you will say that please come to landmark B. Please take a right turn and please come to landmark B. Now he will come to B and he will call you. Now you will say that please come to landmark C. He will come to landmark C and he will call you. Now you will say that please come to landmark Z. There is my house. Now he comes to your house and finally he will reach your house. So here there is one more route. He can directly come from X to Z. So now what happens? He came from X to A to B, B to C and C to Z. There is one more route from X to Z, direct landmark. So but what happened? The first approach which I said is indirect addressing. From X to A, from A to B, from B to C, from C to Z. So whereas in the second approach, direct addressing, he can directly come to your house from X to Z. There is one route. Okay, so this is what direct addressing and indirect addressing is all about. So what is direct addressing? The address in memory of the data. So the address present in the memory, we can directly find out operand, we can directly use that. But what about indirect addressing? First you will go to some address, then it will point out to some other address, then you will go to that address, then it will point to some other address, finally you will reach your operand. So if you see the direct addressing here, this is 457, my address. So what I said, we have 0 to 11, 12 to 14 and this is 15th bit. So 15th bit is I. What I said, if I equal to 0, it's direct addressing. If I equal to 1, it's indirect addressing. Okay. So here 457 is my address. So what I will do, I will directly come to 457. And remember, this is direct addressing. In 457, I found my operand. So what I will do, I will add that with accumulator and the result is stored in accumulator. Why? Because why to store in accumulator? See, I will say an example here. So why to storing in accumulator? So here we have 3 address code. So what is 3 address code? For example, I have add A, B, C. So what I will do? I will add B plus C somehow and I will store the result in A. So no problem with that. So if I have 2 address code, so for example add A comma B. Okay, so what I will do, I will add a and b and the result is stored in a. So a plus b and the result is stored in a. So what is two address code here? So coming to two address code, add two address code is over, right? One address code. So what is one address code? So I have only a, right? So what will a added with? So a will be added with pc. So what is pc here? So pc is a ac is an accumulator and the result is stored in accumulator. Okay, so for one address code what happens? A, we left with only one operand, right? So A will be added with AC and the result is stored in AC. So what is AC here? AC is accumulator. Okay, so that is what we have, only one operand, right? So that operand, for that reason we need to add with accumulator and the result is stored in accumulator as well. Okay. So coming to the indirect addressing. So what is indirect addressing, which I said to you? So indirect addressing, we have address 300. So if it is direct addressing, directly if we go to 300, we will get our operand. But if we go to 300 addressing, it is pointing to 1350 address. So again we are going to 1350 address. There we find our operand. So which is an indirect addressing. So here directly we will find the operand. Here first we will go with address in the memory of the address in the memory of the data which we use. Again it is added with accumulator and the result is stored in accumulator. So this is the difference between direct addressing and indirect addressing. So here we have an effective address. What is effective address? The address that can be directly used without modification to access an operand for a computation type instruction or as a target address of the branch type instruction. So next classes we'll discuss about what is this branch type instructions, what is this computation type instructions and all. So I hope you understood the addressing modes. So what is addressing modes? Direct addressing, indirect addressing. So what is direct addressing here? So direct addressing, the address in the memory of the data to use, directly we will find our operand, but in indirect addressing, it points to one addressing location. If we go to that address location, it points to another address location. If we go to that address location, it again points to another address location. Finally, we will find our operand. So there we can find our data. So this is the difference between direct addressing and indirect addressing. So hope you understood the concept of what is an instruction, what is an instruction codes, what is an instruction format, what are different addressing modes, what is the difference between direct addressing mode and indirect addressing mode. Okay, the students who are watching my channel for the first time, I request you to please subscribe my channel. Please share my videos to your friends WhatsApp groups who are studying in different other colleges so that you and they will get benefited. So and please support my channel in all possible ways. Thank you very much and have a wonderful day.